theory of friction or friction force. Let us take one object. So let this is body 1, which is resting on a ground, let us say. So this is the another object, body 2. So it may be ground or it may be any fixed surface. So this body 1 is resting on a body 2, which is at static condition. Now, as we know, the weight of the body will be acting vertically downward. Then there is a normal reaction upward. So what is N? N I'll write here. N is the normal reaction. W is the weight of body. The body 1. Now let us say a force P is applied on the body 1. Then, as we know, when the force applied on the body 1 in this direction, the friction force will be opposite direction. So I can mark either in this same direction or I can also mark. So both are same. So I will mark at the bottom. So this is the direction of friction force. So I will show you with another color. Or you can mark here also, no problem. The direction is important. So this force P, force F is a frictional force. Force P is a applied force. So P is the applied force, and F is the friction force. Now, this F is a frictional force acting because of this applied force P, and the normal reaction N is because of weight. So when the weight is acting downward, normal reaction will be upward. When the force P applied in this direction, the friction force will be opposite to body motion, because body is moving like in this direction because of this force P. So friction force will be in the opposite direction. So now I want to calculate the resultant of friction force F and the normal reaction N. So there is a reaction force which is acting between these two. Let R is the resultant reaction. What is R? R is resultant reaction. Let the angle between the normal reaction N and the resultant reaction R is, let us say, pi. Now, so parallel to this friction force, I can also mark here. So this is also the friction force F, because this friction force F in the same direction I can mark anywhere as per the law of principle of transmissibility we have seen in the previous lectures. So this friction force either you can mark here and you can also mark here without changing its direction. So now let us take tan pi. We know tan theta equal to opposite by adjacent. So its opposite value is the friction force F and its adjacent value is the N. So this is the normal reaction, means this total line will be representing the normal reaction. So opposite to pi is the friction force F, adjacent to pi is a N. So in this case, this pi, which is the angle between normal reaction N and the resultant reaction R, it is known as the angle of friction. Pi is called angle of friction. So you can calculate the angle of friction with the help of this formula. So that is pi equal to tan inverse friction force F divided by normal reaction and the angle of the friction. But from the concept of the friction, if you just observe the diagram here, always this friction force F will be proportional to normal reaction, because you can see here when the weight is acting downward, normal reaction will be upward. So as long as the friction force is increasing because of applied force or because of change in weight or because of the roughness of the surface, if the friction force will increases, then proportionally this normal reaction N will also increase. So that is from the theory of the friction, from this concept you can understand this. So the friction force F is directly proportional to normal reaction, means and F increases, the normal reaction will also increase. If friction force F decreases, N will decrease. So we know if you remove this proportional symbol, we get a constant. So that is nothing but mu N, where this mu is known as coefficient of friction. Coefficient of friction, it depends on the given surface. Now the range of the mu will changes from 0 to 1. So this value will change for different surfaces. For ground surface, there is one value. You take some wooden surface, it is having some value. So this coefficient of friction mu will depends upon the roughness of the surface, which is between 0 to 1. This is the range of the mu. Now from this I will write mu equal to F by N. So now you just observe this equation 1 means the formula 1 and formula 2. Just compare these two. So if you observe here, this is F by N is equal to tan pi. So F by N is also equal to mu. So this is the coefficient of friction which depends on surface, whereas pi is the angle of friction, which is the angle between the normal reaction N and the resultant reaction R. So if you equate these two, so the final equation which we are getting is tan pi equal to, from equation 1 I can write this as F by N, and this is also equal to mu from the equation 2. So we can use the formula depending upon the given data. Suppose if only F given, N given, you can use this formula to calculate angle of friction. Suppose other than this, if mu is given, let us say N is given, you can calculate F. So like that, depending upon the given data, you can go for the relation to calculate unknown values with the help of given values. Now, so we are talking about angle of friction here. So first let us define what is angle of friction. So this angle of friction can be defined as, it is the angle between the normal reaction N and the resultant reaction R. So let us define the angle of friction. Angle of friction, so let us see the definition. So it is the angle It is the angle between. The previous diagram you have seen N, that is the normal reaction, and the resultant reaction. So what is the definition of the angle of friction? Angle of friction is the angle between the normal reaction and the resultant reaction. Now let us define the limiting friction. So limiting friction is nothing but it is the maximum value of the friction. So simply we can define this limiting friction as it is the maximum frictional force. Or simply friction. So this we write as F max. F max is nothing but the limiting friction. So in the equation we will be using F max. So it does mean that it is a limiting friction. So this is about the angle of friction and limiting friction. Now let us discuss the concept of a body which is resting on an inclined plane. So to know that, so you have to define some terms like angle of repose, theta. The angle of repose with the help of a simple diagram. So a body is resting on a inclined plane. So you can see this symbol. This symbol we will be using for the fixed elements. So this body is resting on inclined plane. So let this angle is theta. Then now, so the angle of this inclined plane, so which is at this angle is, let us say, so I will increase the angle of this plane like this. Means I am increasing this angle. So at some angle, this body will try to move downward, right? So when you increase this angle of the inclined plane, now this is the inclined plane, you can see. So when I am increasing the angle of the inclined plane like this body will try to move downward. So that angle is known as a angle of repose. So now we can definition. Angle of repose. So the another word for the repose we can use as sleep also. Sleep or repose. Angle of repose is the angle at which body just starts moving downward. Just starts moving downward. The definition is very simple. Increase the angle of the inclined plane. At some angle, this body will try to move downward. That angle we are calling as a angle of repose.